Assalamualaikum warahmatullahi wabarakatuh and good day to Doctor. My name is Saris Munazah binti Teresa and my metric number is E190061. This is the result on experiment 4 in lab 4. Okay. In figure 4.1, the layout plan with the socket outlet put according to the location. So this is the layout at my home. Okay. In this experiment, students have to make sure all lighting and power circuit at home function well. We have to turn on, turn off all lighting, switch and socket outlet at home. And then we have to record all the result we to do to test the lighting switch and socket outlet on the table 4.1. Okay, in this table is for MCB and the related socket outlet. And then after that, we have to record the video that we do the test for lighting switch and socket outlet. So I will show the video that I do experiment to test the for lighting switch and socket outlet. Okay, I will show the video that I record for testing the lighting circuit. Turn on, turn off. Only one switch for the lamp. To turn on for the lighting circuit, to turn on and turn off the switch on the lamp in the roof. Okay. When I turn on the switch, the lamp will be on, and then when I turn off the switch, the lamp will be off. I will show again. When I turn on the switch, the lamp will be on. When I turn off the switch, the lamp will be off. For the performing the power circuit, I will show again the video that I record before in experiment 3. This is the body board. This is the distribution board at my house in my living room. Okay, I want to check the socket outlet number 1 and socket outlet number 2. So, based on the MCB, firstly turn off all of the MCB here. Okay, the MCB is total 12. Okay, so I will turn on the MCB of 12, number 12, and then the rest is will off. And then go to socket outlet number 1. I will turn on the socket outlet number 1. Then the phone is connected. The charging phone is connected with the charge. The phone. It means the socket outlet number 1 is related to the MCB of number 12 here. But okay, when I turn off the MCB of 12 and the socket outlet is still on, I will turn on, off, and I will turn on. But the phone is not connected with the charge. It means the socket outlet of number 1 is related to the MCB of 12 here. Okay, next I will show for the socket outlet of number 2. This is the socket outlet of number 2 in my living room. Okay, I will check it. Okay, go back to the body or distribution board. Okay, I will turn on the MCB of 12 here and the rest all is off. Okay, back to the socket outlet of 2. I will turn on and then go to the phone. See, we can see the phone is charged. It's connected with the charge. It means the socket outlet of number 2 is related to the MCB of the here. When I turn off the MCB of number 12 here, the socket outlet is still on, but the phone is not connected with the charge. It means the socket outlet of number 2 is related to the MCB of the hair. After that, in this experiment, we have to draw the single line diagram for the electrical supply system in the house. 5.1. Discuss the purpose of grounding in electrical wiring installation. Grounding is used in electrical wiring to carry electrical current only in the event of a short circuit or other potentially dangerous events. The electricity will travel through the ground wire if a short circuit occurs, resulting in a blown fuse or tripped circuit breaker. It's far preferable than the potentially lethal shock that would would occur if the current was not grounded. Grounding in electrical wiring installation is important for a variety of reasons. First and foremost, there is overload protection. It protects against the home and others from power surges. The system is exposed to dangerously high volts of electricity if lighting hits or the power surges at the location for whatever reason. If the electrical system is grounded, all surplus power will flow into the earth. Furthermore, the voltage levels have been stabilized. A grounded electrical system also makes it easier to supply the right quantity of electricity to the right places, reducing the risk of circuits being overloaded and blown. The earth serves as a common reference point for multiple voltage sources in an electrical system. Furthermore, damage, injury, and lives can all be avoided if the system is not correctly grounded. Any equipment connected to it could be fired beyond repair. In the worst case scenario, an overload of power could cause cause of a fire, resulting in not only significant property and data loss, but also serious damage. Okay, that's it for me. Thank you.
Hello, Assalamualaikum. My name is Syamil Bakri bin Ibrahim. My metric card is CE190170. So today I would like to explain about this Lab4 MPE, which is require us to do the load and lightning circuit combined with power circuit. As you can see, I already put the house plan layout here with the MCB, load, and the switch socket outlet. Okay, this is the table that I put. MCB turns on. For number 1, 20 ampere is living hall, which is 3 socket 7 load. Number 2, room 1, 2 socket 4 load. Number 3, room 2, 2 socket 2 load. Number 4, room 3, 2 socket 2 load. Number 5, still same 20 ampere, living hall 2, 3 socket 6 load. Number 6, room 4, 2 socket 2 load. And lastly, the kitchen, 1 socket 5 load, which is 4 lamp and 1 fan. So this is the schematic diagram with single line that I have drawn. Okay. Okay. So the question for I do the question 5.2, which is name 2 types of conduits that commonly used in electrical wiring. Firstly, electrical metallic tubing (EMT). Second, rigid metal conduit RMC and IMC. So after this, I'm going to continue for the lightning circuit, which is I will test on the MCB and test which lamp and which load and the socket is turned on. Okay. Hello, Assalamualaikum. So I'm going to continue for this MCB circuit for this lightning circuit for MPE Lab4. So I will switch off the MCB in my room. Okay, my room. Okay, and then I will on the MCB back. Okay. Okay, this is my room. I will check the load and the socket is whether it's switched on or not. Okay, I will turn on. Okay, this is the lamp and then this is the fan. Okay, so I'm trying to see the socket. Okay, already on because my LED here is on. Okay, so my socket and my switch is already on while I on the MCB, so it's turned on well. Okay, so that's all from me.
Hi, Assalamualaikum. My name is Siti Rasmi. My matrix number AE180077. So this is my house plan, my rented house at Taman University, Parit Raja. So there is 4 rooms, 2 toilet, hall and kitchen in this house. So for the room 1, there is one fluorescent lamp, one fan. And for the toilet one, which is in room 1, there is one lamp. So one switch control the lamp in the room 1, one switch control the fan, and one switch control the lamp in the toilet 1. So next, room 2, there is one lamp and one ceiling fan. So one switch control the lamp and one switch control the ceiling fan. Moving on to the next part, which is toilet 2. There is only one lamp and one switch control this lamp. So next is room 3. There is one lamp and wall fan in this room. So one switch control the wall fan and one switch control the lamp. Next is room 4. Also have one lamp and one ceiling fan. So one switch control the lamp and one switch control the fan. So next, this is the hall. There are two lamp and one ceiling fan. So for this switch, one switch control the lamp and one switch control the fan. So for this lamp, this switch will control this lamp. So next is kitchen. There are two lamp, fluorescent lamp, and one fan. So one switch control this lamp, one switch control the fan, and one switch control the other lamp. So that's all for my house plan. So I pass to the next presenter. So this is my room, which is room 2. In this room, we have two switch here. Let's say this is switch 1 and this is switch 2. And we have 4 plug here. We use this one for fan, extension wire, and to charge our phone. If I switch off the switch 1, this fan will turn off. So if I switch on, the fan will turn on. For the switch 2, if I switch off the switch 2, it will turn off the light. So let's switch on. The lamp will turn on. So moving on to the next part, which is discussion. In this lab, we will be able to identify and recognize single-phase electrical wire installation, distribution boards and their components in residential buildings, as well as design a single line diagram or schematic diagram for the circuit. So to complete this lab, we must first ensure that all of our home's lighting and electricity circuit are operational before turning off the lighting switch and socket outlet. Then on the distribution board, we must turn off all the MCBs. Then by turning on one of the switches, we test the connection between all of the lamp in our house and the MCB. Then we attach a socket tester to a socket outlet and turn on one MCB to test the connection between all of the sockets in our house and the MCB. Turn on the switch and check the socket outlet's operation. So the tables 1 to 3 shows the results. Based on this finding, we can create and identify a single line diagram for the house electricity supply system. So for the next part, I will pass to the next presenter.
A very good day. My name is Putri Nonabila Isma binti Ishaq with matric number AE180049. So as we can see, figure 1 shows the socket outlet or load point on the house plan. So there are miniature circuit breaker MCB, socket plug, ceiling lamp, fluorescent lamp, and fan on the house plan. And then move to figure 2, where it shows the single line diagram for the electrical supply system in the house. For the lighting power circuits, there are 8 there are 8 of them, where it is connected to 6 ampere circuit breaker or fuse. And then there are 7 power circuits for socket outlets, where 6 of them are connected to 16 ampere circuit breaker or fuse, and one of them is connected to 32 ampere circuit breaker or fuse. And then this is the table for MCB and the related socket outlet or load. So this table has simplified the house plan, socket outlet and load. This is a demo in my room, which is room 3 in the floor plan, where both switches are one-way switch. This is the switch for lamp and this is the switch for fan. If I switch on the left switch, the lamp will turn on. And if I switch on the right switch, the fan will start to spin. So this is a testing of the socket plug. As we can see, I am using a phone charger as a load. When I plug in the phone charger and turn off the socket plug, there is no flow of current. And when I turn on the plug, there is a flow of power. In conclusion, single-phase wiring installation is the most common wiring in residential buildings. In single-phase supply, there are 2 incoming cables from the utility poles to the kilowatt-hour energy meter and then directly connected to the main distribution board. The basic components of a building structure are the floors, walls, beams, columns, roof, stair, and others. These elements serve the purpose of supporting, enclosing, and protecting the building structure. These are some benefits of drawing single line diagram for the circuit. For instance, helps identify when to perform troubleshooting and simplifies the troubleshooting process. Next, accurate single line diagram will further ensure the safety of personnel work. Other than that, meets compliance with applicable regulations and standards. Lastly, ensure a safer and more reliable operation of the facility. Thank you.